Oh, welcome back. We have already started chapter number 7, and we did up to, yes, we did up to here, but I'm going to review it again and we'll move forward. You see, uniform circular motion. If a particle moves in a circle, you see in physics, any object, you know, which is whatever we have, an object is small or big, chair or table, a person, a planet, we call them particles. So if a particle moves in a circle or a circular arc of radius r at constant speed v, its motion is called circular, uniform circular motion. What makes a particle to move in a circle? The answer is centripetal force. So what is centripetal force? It is the inward force necessary to maintain the uniform circular motion, F sub c. It is directed towards the center of the circle. It's the center seeking force. Keep in mind that centripetal force is not an actual force like gravitational force, like magnetic force, like electric force. It is provided by some other source. For example, once you are connecting an object with a string or the rope, tension in the string provides the necessary centripetal force for the object to move in a circle. Force of gravity provides, the centripetal force to move Earth, for example, around the sun or moon around the Earth. A force of friction allows you to move in a circle once you are driving your car. Centripetal force is equal to mv square over r. Normally we have Newton's second law of motion. Force is equal to mass multiplied by the acceleration. Since we have a force which is directed towards the center of the circle, so the acceleration caused by that force is centripetal force in the same direction. So when we have a v is equal to r omega, so if I substitute here, v square r square omega square, so I would get finally this one. So we have a relationship for centripetal force, this one with the linear speed v, r with angular speed omega, two different relationships. So it depends what's given to you and what to find out. So this is, as I told you, centripetal acceleration. This is equal to v square over r omega square, any one of these. Okay, so that's all about the centripetal force. And a question arises that when we say that centripetal force is a force, we call it center seeking force. It is acting towards the center of the circle. So the question arises, if it is so, uh, the object may fall in the center, like Earth is moving around the sun, right? This is sun, millions of degree Celsius temperature. So Earth is moving here, of course, directed towards the normal centripetal force. So it may fall in the center where it's very high temperature, but it doesn't happen. Why? Due to uh, this force of reaction, Newton's third law of motion comes to play its role here, which says that there is always a reaction for every action. So we have a reactional force, or centrifugal force, which acts away from the center. So due to balance of these two forces, the object keeps moving in a circle. Now we have seen two types of the accelerations. Once the object is having uniform circular motion, one was tangential acceleration, this one, which is always at a tangent to the circle, and the second one due to the centripetal force, which is the centripetal acceleration, a sub c. Now you have seen that when you have two forces, this is a, for example, you add them with head to tail rule, bring the beginning of the second on the end of the first, and join these two vectors. So this is your resultant. Okay, this is B. Now instead of A, you have, for example, here A sub T, tangential, this direction, same direction I'm using, and the second one down, A sub C. This is A sub C, for example. Okay, and this is your resultant, which is a total. Okay, all right. So this is your resultant vector. So once you have like this one, so you can find this is in the vector form, but if you want to write the magnitude of the total acceleration, of course this is right angle triangle, and we can find out the magnitude. This is A, so with the help of the Pythagoras theorem we can find out A total, so AT square plus AC square, where we have done that tangential acceleration is equal to R alpha or del V over del T, and centripetal acceleration V square over R R omega square. So this is the relationship we have already done. Now we are going to do one example, 7.5. Race car accelerates uniformly from VI 40 to a speed of Vf, which is 60. This is the time while traveling counterclockwise around a circular track of radius r. So the car is traveling like this one. This is your radius. When the car reaches a speed of this, so speed is given to you, find the magnitude of the car's centripetal acceleration. So we have discussed that this is your centripetal acceleration. V is 50, R is given to you, you get 6.25 meter per second square. Then angular speed, we have to find out angular speed. Since we have V is equal to R omega, so it implies omega is equal to V over R, which is V is 50, R is, so you get 0.125 radian per second. Then you have to find out the magnitude of the tangential acceleration. We have seen that we have tangential acceleration R alpha, or another relationship we have del V over del T, because tangential acceleration is simply the linear acceleration. So if I use this rule here, because I have initial and final, the speed changes from 40 to 60. So I have del V over del T. So I have Vf minus Vi over delta T. 60 minus 40 over 10 is given to you 5 seconds. So you get tangential acceleration for Then the magnitude of the total acceleration by Pythagoras theorem, we have done that. A total is equal to a t tangential acceleration square plus at, you just finished 4, and AC, you just calculated here, AC 6.25. So finally you get 7.42 meter per second square, a total magnitude. Now the last question of this chapter. A car travels at a constant speed, okay, constant speed v, okay, on a level circular turn of radius. This is your radius. What minimum coefficient of static friction? So you have to find out mu s between the tires and the roadways. You see, you have the key idea. We have discussed that whenever an object is moving in a circle, it is moving due to centripetal force, and that force is not actual force, it is coming from some other source. So right now the force of friction between the tire and the road gives you the necessary centripetal force to take the turn. Okay, so the force of friction, which is Fs, is equal to the centripetal force, because centripetal force is provided by the force of friction, F sub s, and we have F sub s, mu s, which is coefficient of static friction, multiplied by the normal, and this is equal to mv square over r, centripetal force. So when you are on the horizontal surface, the weight downward and the normal reaction upward, so they are equal and opposite, so opposite direction but equal in magnitude. So in place of normal force N, I can write here mg. So this is mu s. M goes with M, and you get, the mu s, which is unknown. You have to find out v square over r, and g goes down. V is given to you, how much v? 13.4. R given to you 50, and G 9.8. You get mu s finally 0.366. It has no unit because it is simply a ratio between two forces. So this is the end of this chapter, and now we are going to solve the tutorial, chapter number 7. So question number 1. Yes, please. You see, a point on the rim of a wheel radius r. So this is radius r given to you. It is rotating in this direction, for example. Angle theta is given to you. and you have to find out the length of this arc S you have to find out. This is the rule we have discussed in the beginning of this chapter, that you have theta is equal to S over R, so it gives you S is equal to R theta or R delta theta. Now you see delta theta is equal to 2865 degree. We know that 360 degree is equal to 2 pi radian. So SI unit of theta is radian. So 1 degree will be equal to 2 pi by 360 degree, 360 radian, or pi by 180 radian. Okay, so here we use R. How much R is given to you? Multiply by theta, which is 2865, since we are going to convert it into radian, so we multiply with the pi by 180, so it is in radian now. So you get finally S is equal to 8.2 meter. That's it. All right. Next question. A cylindrical cement mixer starts rotating from rest. Starts from rest mean you have omega I 0, angular speed initial. At a constant angular acceleration, this is your alpha 2 radian per second square. So this is your time t. Okay, so this is your time 5 seconds. Through what angle? So delta theta you have to find out. So we have this equation, and since in starting angular speed omega I is 0, so half alpha 2 t 5 square. So delta theta you would get 25 radian. That's it. Okay, now question number 3. A car's wheel rotates at an angular speed of 0.06. So this is your omega I initial. It increases to this, so this is your final angular speed, and acceleration, this is your acceleration. Find the angle through which the wheel rotates before reaching this final speed. So angle you have to find out. We have the third equation of motion for angular motion, plus 2 alpha delta theta, right? So 2 alpha delta theta, if I take it to the other side, you will get okay, you need delta theta, so I take this 2a here down, so you would get so this is 2 alpha, here you have delta theta. Or I can write unknown on the left side better. I wrote it for your understanding, in fact. Square minus 2 alpha omega final, how much? 2.2 initial how much is 0.06 over 2 alpha. Alpha is 0.70, so you get delta theta 3.5 radian. This is your answer. Then question number 4, you see you have this electric motor rotating wheel at the rate of revolutions per second. So this is your omega I, revolutions per minute, RPM. Okay, revolutions per minute. So this is 100 revolutions per minute, so you have to convert. You see, one revolution is equal to 2 pi radian. So before you have 100 revolutions per minute, so 100, so this is revolution, one revolution multiplied by 2 pi, so this becomes a radian divided by minute. 1 minute equals 60 seconds, so you get like this one. This is what I wrote it here. Okay, 2 pi by 60, this is a radian per second. So finally you get this one, omega I. We have the first equation of motion for rotational motion. Final angular speed omega f is equal to omega I plus at, right? So we have, okay, if the wheel has an acceleration, how long does it take for grinding wheel to stop? Once it is going to stop, it means final will be equal to 0. So that's why final becomes 0. This is final, this is initial, and acceleration alpha is equal to -2. It is given to you, okay, -2 radian per second square. So -2 multiplied by t. So if I take this to the left side, I will get +2t 10.47, and finally t will be equal to 10.47 over 2. So you get finally this time 5.24 seconds. Okay, now B part of the question says how many revolutions has the wheel turned during that interval. So you need to find out delta theta, but in revolutions. Keep in mind, SI unit is radian. First you will get your answer in radian, but then you convert it into revolution by using the rule 1 revolution is equal to 2 pi radian. We have this equation, which is the second equation for rotational motion, and we simply substitute the values. Omega I, this is omega I here, you already calculated omega I, and time is this much time, you just finished time here, plus half. Alpha is given to you how much? -2 radian per second square, -2, and then times square. So in this way you get delta theta. If you use your calculator, you will find out delta theta 27.4 radian. Now, as I told you, that one revolution is equal to 2 pi radian, and we have to divide it to get in revolution. So you get 4.36 revolution as your answer. All right. Question number 5. An object, mass is given to you, attached to a string, is swung at constant speed 5 meters per second. It's rotating like this one. This is the tangential speed. In fact, this speed, tangential speed is always at a tangent to the circle all the time, right? A radius is given to you. Find first of all angular velocity omega. We know that v is equal to r omega, so you get omega is equal to v over r. V is given to you 5, r is given to you 1.2, you get omega 4.17 radian per second. Second part, tangential acceleration a sub t. You see, we have two relationships for tangential acceleration, this one and right. Now, since we are given tangential or linear velocity, it is constant. What does it mean? It means initial and final same, so you'll be getting the 0. It is constant, right? Initial and final 5, both 5 minus 5, 0. So you get acceleration 0. Number 3, centripetal acceleration. We have two relationships for centripetal acceleration. We have v square over r and we have r omega square, right? Since you have omega, so you can find out with the help of this formula, r omega square. R is given to you, this r. Omega you just finish here, this is omega, you get this one. Right? And if you use this rule, you should get your answer close to this one. Right. Now we have number 4, total acceleration magnitude. We have seen many times in the previous lecture. A total is equal to at square plus ac square under the root. You have at 0. You have ac 20.9. You will get this as a total acceleration magnitude. And number 5, centripetal force is having two rules. Fc is equal to mv square over r. Okay. Or you have the other rule also if you convert it into v is equal to r omega. So you can use the two, any of the correct rule. So this is m is given to you, v 5 square, and r is given to you. So you get, the centripetal force magnitude this much. Then please write down, I have already solved it for you, question 6 and 7. Fill in the blanks. The average angular speed of a rigid object is defined as the ratio of the angular displacement to the time interval. This is what we did. Average is equal to delta theta over delta t. The tangential speed of a point rotating on a rotating object equals the radius of the radius from the axis of rotation multiplied by the angular speed. Alright, so this is what we have done there. Okay, the acceleration of objects moving along a circular path toward the center of the circle is known as centripetal acceleration, A sub c. Okay, angular displacement is the difference between the final and initial. Then match the column. Angular acceleration, this is the unit. Tangential acceleration, was equal to r alpha. Okay, centripetal force is acting towards the center always, and angular displacement unit is radian, SI unit. Better you write SI. Okay, that's it, and thank you very much and have a nice day.